In this video, we are going to start looking at the polar form of a complex number. Let's start with the complex plane. Recall a complex number is a number of the form a plus bi, where a is said to be the real part of z, and b is the imaginary part of z. We'll associate the real part of z with a real axis, and the imaginary part of z with an imaginary axis, so that each complex number a plus bi can be associated with a point AB in the complex plane. For example, the complex number -4 plus 2i would be associated with a point that's 4 units to the left and 2 units up. The complex number 2 plus 3i would be 2 units to the right and 3 units up. While the complex number -3i, that does not have a real component, would not be to the left or the right. It would be just 3 units down on the imaginary axis. Now that we can plot some points in the complex plane, let's look at the modulus and argument of a complex number. If a plus bi is a complex number that can be plotted in the plane at the point AB, and r theta is a polar representation of that point, then the modulus of z is defined as that distance r from the origin. And since this is a right triangle with side lengths of a and b, then the modulus is just that distance found by the Pythagorean theorem. And the argument of z is going to be the set of all the angles that describe that rotation. We'll usually be interested in the principal argument of z, which will be an angle between -pi and pi. To find the angle theta, we'll note that for a right triangle with sides a and b that are known, the tangent of theta will always be that opposite side over the adjacent side. Now we're in the position to define the polar form of a complex number. Given a complex number a plus bi that can be plotted in the complex plane at the point AB, with modulus r, that distance away from the origin, and argument theta, that rotation, then the polar form of the complex number is r cosine theta plus I sine theta. To obtain this, well, soon to be familiar form, let's note that for a right triangle with side lengths of a and b, that the cosine of theta, now cosine of theta would be the adjacent side a over the hypotenuse, gives that a is r cosine of theta. And the sine of theta, now the sine of theta would be the opposite side b over the hypotenuse, which gives b is r sine theta. So that by substituting in for a and b, we have r cosine theta plus r sine theta. And since each of these terms have a common factor of r, we'll pull the r out to get the familiar form r cosine theta plus I sine theta. This is sometimes abbreviated as just r cis theta. Let's look at some examples. Let's find the polar form of the complex number -3 plus 3i. To start with, let's graph this point in the complex plane. And so the negative, let's see, so this would be a complex number that was 3 units to the left and then 3 units up. And so it would be at the ordered pair -3, 3. To write this complex number in polar form, we'll need to find our modulus, our distance away from the origin, r, and our argument theta, this rotation. To find our modulus, we note that we live on a right triangle with side lengths of 3. Well, they both have a side length of 3, so that the modulus r would be, well, by the Pythagorean theorem, it'd be the 3 squared plus negative 3 squared, which is, well, this would be 9 plus 9 is 18, or 3 square root of 2. Our argument theta can be found by looking at the tangent of theta, and the tangent of theta would be the opposite side 3 over negative 3, which gives tangent of theta is negative 1. In the second quadrant, we identify this happens when theta is 3 pi over 4. So that our complex number z can be written as, be our modulus r, 3 root 2 times the cosine of 3 pi over 4 plus I sine of 3 pi over 4. Or in shorthand notation, it would be just 3 root 2 cis 3 pi over 4. This would be the polar form of our complex number. Let's look at one other example. Let's find the rectangular form of a complex number. The rectangular form of a complex number can be found by expanding this expression out. This would be 4 cosine of 2 pi over 3 plus I sine of 2 pi over 3. Of course, you know the cosine of 2 pi over 3 on the unit circle is negative 1/2. The sine of 2 pi over 3 is square root 3 over 2. And now we'll distribute the 4 into the brackets. The 4 times the negative 1/2 gives us a negative 2. 4 times the root 3 over 2 would give us a plus 2 root 3 I. And this is the rectangular form of our complex number. I hope this was helpful, and I'll see you guys next time.